Hello, my name is Mike Miller, and I'm a stream ecologist with Wisconsin's Department of Natural Resources. If you're seeing and hearing this presentation, evidently Dan Kendall from the state of Iowa and others have figured out the technology. What I want to do today, or this morning, over the next 20 minutes or so, is provide an overview of some sampling efforts in the state of Wisconsin to better understand the contamination of the state's streams and rivers by pesticides. I suspect Sean Giblin has gone through the literature in much more greater detail than I plan to do in the next 20 minutes or so. So you can kind of view this presentation as a Miller Lite overview. I spoke to this audience previously on the topic of neonic contamination, so I don't want to necessarily revisit all those topics covered in that previous presentation, but I do think there's a few issues that I'd like to revisit just because I think it's fundamentally important as far as it relates to the use and management of these chemicals. And then I'll spend a little bit of time talking about the survey design we use in 2022 to assess streams and rivers in the state of Wisconsin, and then also the toxicological benchmarks we use to assess the contamination of the state. And then finally, I'll present those findings as far as what are the overall levels of contamination in the state of Wisconsin, our streams and rivers by various neonicotinoid compounds. I suspect most of you know that neonicotinoids are used in a number of different applications, whether it's topical dressings on livestock or pets, or use as root drenches, again, granulated applications on green fields, ball diamonds, that sort of thing. But we should recognize, or the audience should recognize, that by far and away the primary use of neonics, at least in the upper Midwest, is on seed dressings prior to planting. Neonics are extremely toxic to invertebrates. A lethal dose for a honeybee is 5 billionths, again, billion with a B, of a gram of neonics is enough to kill a honeybee. And I'm using this analogy of sugar granules, and again, that quantity being sufficient to kill thousands of honeybees. Perhaps a strong term, but producers of neonics have conspired with corn seed producers, making it nearly impossible for ag producers to purchase seed that are not coated with neonics and other chemicals. So again, even if they have a desire not to use these chemicals, they have little choice when purchasing seed. I suspect that many of you are aware, and perhaps Sean Giblin pointed this out in his presentation, the use of these chemicals over time. You can see in this histogram plot where, again, these chemicals were neonics first became commercially available in 1993, and their usage over time has increased dramatically. I'm not sure if Sean had mentioned the fact that since 2014, we no longer have information on usage in the United States. Chemical manufacturers have exploited a clause in the FIFRA Act where these chemicals, when they're applied to articles, whether it's a corn seed as far as insecticides are concerned, or for example of some bactericidal chemical on your kitchen sink sponge, then they're no longer tracked as pesticides. So again, we see this tremendous uptick in the use of these chemicals, but we have in essence no data since 2014. So as you can read here, the preemptive use of pesticides has led to the abandonment of long-held principles of integrated pest management, things like rotating your crops to avoid buildup of crop pests over multiple years, or monitoring for pests and not using chemicals unless they're necessary, or this idea of avoiding broad spectrum pesticides, but use chemicals that are target specific pests, or one other example is the avoidance of using persistent chemicals. There's a large and growing number of studies showing impacts to various terrestrial and aquatic invertebrates. So the ag producers that are purchasing treated corn and other seed types are paying for these chemicals. So what are the benefits to the grain producers? What I'm showing here, this citation of Grout et al. Grout and others were researchers for the Cornell University. They put out a massive report, roughly 450-page compendium on various studies on the effects of neonics in the environment and also the benefits accrued by using these chemicals. And very interestingly, they show that they looked at hundreds of field trials comparing test plots where the corn was treated with neonics prior to planting and comparing those with, again, corn seed that were not treated prior to planting. You can see here for corn that the vast majority of the field trials show that there was no increase in crop yields as a result of using these chemicals. And for many of the studies, the relatively small percentage of studies that did show increases in crop production, the improvements in crop production were fairly negligible, where oftentimes they didn't offset the cost of the chemicals themselves. So again, the environment's suffering from these chemicals, and at least with the corn, we're not seeing much evidence of benefits, again, when we're applying them to the seeds. And the same story holds true for soybeans. Again, same situation, multiple states, several Canadian provinces, hundreds of field trials, each providing strong evidence that the use of these chemicals when applied to the seeds have little benefit to the ag producers. So next I'm going to talk about the study we conducted in 2022 to assess the contamination of streams and rivers in Wisconsin by neonics. So I used survey design and data interpretation tools developed by the US EPA's National Aquatic Resource Survey effort. Again, these are probabilistic surveys where each resource, whether it's a stream or a lake or wetland, whatever, has a known non-zero probability of being sampled. So a fairly rigorous statistical design used for this study and throughout the NARS effort. Some of the details of the Wisconsin study. Again, I looked at Strahler first through seventh order streams and smaller rivers in the state of Wisconsin. By the time a stream is about a Strahler fourth order, perhaps fifth, they become non-weightable. Since Sean Giblin had been collecting data on the Mississippi River and some of the larger tributary rivers to the Mississippi, to avoid overlap in that with his effort, I stuck more towards smaller stream and rivers in the state. Again, we stratified by land use. Again, since these chemicals are applied primarily in agricultural and some examples or instances in urban landscapes. Again, in urban areas, neonics are applied on green spaces, whether it's parks or ball diamonds, soccer fields, that sort of thing. So again, they do show up in urban areas as well. But again, obviously, we're more likely going to find these chemicals where they're primarily being used, and that in the state of Wisconsin is primarily agricultural land use areas. We use an unequal probability design where if we did a solely random sample of a stream site, since there's many more small streams and large streams in any given watershed, we weighted the larger streams slightly heavier, so we made certain we had some usable number of larger streams accounted for in the survey design. In essence, what we did, we took a hydrography layer for the state and overlaid a DOT roadway layer. So what we ended up with is 46,000 road stream intersects, i.e. bridges or culverts. So it helped expedite the sampling process. Again, of those mere 46,000 sites, we did a sample draw of 115 sites. We also collected trend data from 3 different watersheds, 15 different streams at 19 different locations total. Just to kind of expedite the process here a little bit, I'm not going to report on the trend data, but we sample roughly every 2 weeks. And at least once a month we ended up sampling a storm event, so we were able to see how the concentrations of these chemicals change over time within these respective streams, and then also what were the effects of storm flows. So this graphic shows a distribution of the sampling sites across the state and the different land use strata that we used. You can, again, they're listed here, the land use types and also the number of samples collected within each one of these strata. You can notice that cluster of orange dots in the center, which represents watersheds that are dominated by heavy vegetable crop production, so things like potatoes, carrots, snap peas, etc. When the last glacier moved through the upper Midwest, there was a ice dam in the center part of the state, and a lot of meltwater from the glaciers gathered there. And when the dam broke, it left a lot of sand in that particular area of the state. It's known as a central sands area. It's pool table flat, and the soil, again, is dominated primarily of sand. So it's a great place to produce vegetables, and with vegetable crops, they oftentimes apply heavier rates of neonics and other agrochemicals to those types of crops. And again, we also looked at some sites in urban areas, since Milwaukee, which is in the east central part of the state, is the largest urban area in the state. A lot of the random sites ended up landing in that urban area in southeast Wisconsin. And then also we looked at row crops. I'm defining row crops as corn and areas of corn production and soybean production, which it tends to be more dominant in the southern part of the state. And lastly, that stratification of other. In essence, what that means was watersheds dominated by land uses other than urban areas and vegetable cropping areas and row cropping areas. And that could take those four strata and combine that into a statewide assessment. So I'm using data from 115 randomly selected stream sites to characterize 46,000 stream and roadway intersects in the state. So can we have any confidence that data tells us much about, does it have much statistical power to tell us much about the conditions of the state's waters? Many of you are familiar with power analyses, where the question you're trying to answer is, what is the mean concentration of neonics in some population of streams in this example, and what is the error associated with that estimate of the true value for that population? So that power analysis is strongly influenced by sample size. The interpretive tools we use for this study are known as proportion estimates models, where the question we're trying to answer there is, instead of trying to answer questions about the mean, what we're trying to answer is what proportion of the streams in the state have a neonic concentration of X or concentration of Y, that sort of thing. And using a proportion estimate model, you can use a relatively small population of streams in this example to extrapolate to the much larger population. So ideally you want to have roughly somewhere between 30 and 50 sites within each strata, which I did not achieve. And again, once you get beyond about 30 sites, the kind of return on information drops off fairly dramatically. So the point is, the data we have tells us a fair amount, but ideally we should add more samples analyzed. But again, we can clearly describe the power of these data using this particular sample data interpretation. So with the study data, we wanted to describe the level of contamination found in streams and rivers across the state. And also what we'd hoped to do was also make some statements about, what are the potential ecological impacts of these various levels of contamination as well. And so in order to do that, we took toxicity data from a variety of different studies, whether they're from various university researchers or the U.S. Environmental Protection Agency. So two key benchmarks used are shown here. One was a study by Morrissey et al. In 2015, and also some aquatic life benchmarks from the U.S. Environmental Protection Agency. In regards to the Morrissey et al. Study, what they had done is they took data from 29 different laboratory studies of aquatic invertebrates. Most of them were insects, some crustaceans, I believe. Actually, I don't recall all the sources of data for the EPA aquatic life benchmarks. But back to the Morrissey study, again, it's thought that these various neonics, these multiple chemicals, can have additive effects, or I should say they have similar modes of action. So regardless of whether it's imidacloprid or clothianidin, they are the same types of nervous system disruptors in their effects. So the thought being is that if you have multiple chemicals, different types of neonics in a water body, for example, their concentrations can have an additive effect. So again, based on these studies, Morrissey and others concluded that, as you can read here, that levels between 35 and 199 parts per trillion can have chronic effects on aquatic invertebrates, and then concentrations above that are thought to have acute toxicity. The aquatic life benchmarks for EPA, as you can see here, are chemical specific. Again, as you can see, one being clothianidin and the other one being imidacloprid. We also use data from a more recent study by Janiga and others in 2023. They're researchers at the University of Wisconsin-La Crosse and also University of Wisconsin-Whitewater, where they dosed fathead minnow eggs in fry, and they concluded that at concentrations of clothianidin, as you can read here, greater than 160 parts per trillion, they're seeing mortality in the fry. And they also provide some evidence on physiological or perhaps behavioral changes as well, where there's less of a startle response by the hatched fry and other factors that were interpreted to be behavioral impacts from these chemicals. So lastly, I want to provide findings from the Stream and River Survey from 2022. So based on information in the literature, we were expecting to see upwards of 5 different neonic compounds being detected in Wisconsin streams and rivers. But as you can see by the findings from the 2022 study, only 3 of them showed up in any measurable concentrations. Again, as you can see here, clothianidin being the most frequently detected neonic, followed by imidacloprid and then thiomethoxam. And also important, should be recognized that in a high proportion of the streams, more than one neonic compound was detected at any given time. So I suspect Sean Giblin has presented some information on some work done by Travis Schmidt and others, where they looked at some of these compounds in concert, where it's, some researchers suspect that these chemicals have an additive effect in the environment, but based on findings from Schmidt and others' work, looking at models and mesocosms and I believe some lab tox studies, that actually for things like clothianidin and imidacloprid, when they're found together in the environment, they can have a synergistic effect on organisms. So again, another kind of facet of this data I need to explore in a little more detail is, the number of sites that have commingling of these different chemicals. So the box and whisker plots shown in this graphic illustrate the range of concentrations of total neonics found in streams based on various land use types. And as you can see here, the watersheds dominated by vegetable cropping land use have the highest concentrations of total neonics. Again, I'm using the thresholds or benchmarks provided by Morrissey to illustrate those concentrations that are thought to be either acutely or chronically toxic to aquatic invertebrates. So using US EPA aquatic life benchmarks, again, those concentrations of either clothianidin or imidacloprid that once exceeded is thought to impact aquatic invertebrate life, we can make some estimates of the proportion of streams in the state of Wisconsin in these various land use types that are impacted by these chemicals. And again, using the data from all 4 strata that could be incorporated into a statewide survey of, again, proportions of stream impacted by these chemicals. Based on the benchmarks developed by Jeniga and others in 2023, where they were seeing mortality and behavioral effects in fathead minnows at concentrations, water column concentrations of clothianidin above 160 parts per trillion, we can make some estimate of the percent of streams in the state of Wisconsin where we may be seeing impacts to fish based on clothianidin concentrations. Again, one thing interesting to note here is that in all the previous results, we saw that watersheds with vegetable cropping tend to have the highest concentration of total neonics and greater impacts to aquatic invertebrates. Clothianidin is used to a lesser extent in vegetable cropping areas as compared to corn and soybean production areas. So again, we see kind of a shift in the impacts to fish based on the use of clothianidin. So I failed to mention at the start of my presentation, the water samples we collected across the state were split, and those samples were sent to 2 different laboratories. Again, the Wayne State Laboratory analyzed for 5 different neonic compounds, and an EPA lab in Athens, Georgia, did a scan on a much broader suite of chemicals. We're just now getting some very provisional data back from the EPA lab, but the point I want to make here is that the focus has been on neonics, but based on these very cursory findings from the EPA lab, as you can see here, for a small number of samples collected in just 1 month in 2022 in midsummer, upwards of nearly 56 different compounds in addition to the neonics were detected in the stream water samples. So at this point, that one can kind of throw their hands up in despair and wonder how do we address this? But I suspect Sean Giblin has touched on some of the tools that EPA and USGS have developed, where we can focus in on a fairly core group of chemicals that we can assess to get a better understanding of impacts of pesticides to aquatic life. So to quickly summarize, presentation one, again, we got this widespread prophylactic use of neonics, oftentimes when there's no threat of insect pests in the crop fields. Two, the very compelling and important study done by Cornell University, where at least the use of seed-applied neonics appears to have little benefit for ag producers. And lastly, based on the survey work from 2022, we're seeing what I consider significant concentrations of neonics in Wisconsin streams. So I'm not certain what sort of connectivity I might have as far as being able to log into this meeting today. So again, if I'm unable to answer your questions directly, remotely, I should say, feel free to email me and I'll try to address your questions. I appreciate your time and I hope this presentation was of value to you. Thank you.